Glenn.
Hi.
Hi.
All right. Well, I guess I'll go ahead and start since it's time for me to do that.
Yeah.
So
yeah.
this is GroupBy 2020, obviously, and this is the first day, the American side of it. And this is the High Availability Disaster Recovery 101. And this is my Yay Me slide here. And the important thing about this is my contact info. So my blog and my email
I love
address
that.
and my Twitter handle. And I also have a YouTube channel, so please check that out. And I know how to brew beer. I've been doing home brewing for about 5 years. I do 5-gallon batches of all grain beer. And it's a really fun hobby that I enjoy. I built that little cart there, and it takes about 5 hours to make a batch of beer, and then you drink it about a week to 2 weeks later. And also, here's what some of my beer looks like. And I enter competitions, and sometimes I win medals. So that's kind of my main hobby. And so what we're going to talk about is
Nice.
why do you have downtime and data loss? And how do you go about planning an HA strategy? Because a lot of people just make a mistake of let's just use availability groups because that's the new shiny thing. And we're going to talk about the different availability technologies that SQL Server 2019 has that are part of the product. And we'll talk about how to plan a disaster recovery strategy and also some things that have to do with SQL Server 2019. So what is high availability? Because a lot of people have that basic question. Well, it just means that something is available to be used as you expect it to be. And in our context, it usually means a database. So a database behind a web server or an application. You want to make sure that that's available no matter what bad things happen to it or other parts of the infrastructure. And you do things to try to make sure that it's always available. And there's lots of things that you could be trying to protect. There's different levels of what we're talking about here. So it could just be a single table that you really care about, that you want to make sure is available. So you could use transactional replication to protect one table in a database. But more often, it's just an entire database. So you might have something that protects one database or a group of databases. And it could be a server. You're trying to make sure an entire server is always available. And there's things you can do to try to protect that server, like failover clustering. And it could be in a data center. You want to make sure that the data center is always available. And if it's not, that you have a secondary data center. So there's lots of different scopes here that we're talking about. And downtime and data loss are a big deal if you're a DBA. That's kind of your primary job, to make sure you minimize your downtime and you try to never have any data loss. And so you can have planned downtime and unplanned downtime. And a lot of DBAs, they're judged on their reviews and bonuses on how well they hit these metrics. So common reasons for planned downtime is performing some sort of database maintenance is one of the common reasons. So if you have SQL Server Standard Edition and you don't have online index operations and you have to create an index on a really large table, that's going to lock up the table while it's doing it. And that's going to cause an outage depending on how big the table is and how fast your infrastructure is. So Enterprise Edition has online index operations. That's one of the main reasons a lot of people will spend the extra money for Enterprise Edition just for that one feature. And you also have resumable index operations in SQL Server 2017 and newer, which helps you can stop something like an index rebuild and then start it up again later without having to start over again. So that's helpful. Another reason you might have to take planned downtime is if you know you've got a table with billions of rows in it and you need to delete hundreds of millions of rows from it. Well, the quickest way to do it would just be a set-based operation, just delete from that table all in one shot. But if it's a really large table and you're trying to do that in one shot, that's going to lock up the table and cause an outage. So one way around that is to have a batch that just nibbles away at it and takes a lot longer. So dealing with a lot of data like that can cause you to let's just take an outage and do it at 1 a.m. when nobody's using it. But probably the most common reason you have planned downtime is doing some sort of an upgrade. So installing a SQL Server Service Pack or cumulative update, or installing Windows updates or firmware updates or a BIOS update, things like that on your servers can cause you to take a planned outage to do that, a maintenance window. And one thing you can do to minimize your downtime is have some sort of HA topology in place. So you can do what's called a rolling upgrade. So for example, if you're doing an availability group, you can patch one replica and then fail over and patch another replica. And then you're only down for the failover time instead of, if you had a standalone server, if you have to bounce the server, you'll be down for several minutes or longer depending on the server. So unplanned downtime is something you don't want to have happen, but sometimes it just does. It's outside of your control. So you could lose an entire data center, a natural disaster. And it depends on where you live. If you live in Florida or Puerto Rico, they get hurricanes a lot, unfortunately. So a hurricane could come in and take out your entire data center. So different kinds of natural disasters are going to affect you based on where you live. Fire can be an issue in some areas, losing power for an extended period, although most data centers have diesel backup generators, but how long is that going to last? Another reason is maybe somebody has a backhoe and they cut through an internet line and then the data center is offline for a while. So that happens sometimes. And if you're worried about that, there's things you can do to try to mitigate that. Another reason you might have unplanned downtime, it doesn't happen as much anymore, is the server just fails. So some part in the server, like the motherboard or the power supply or memory, goes bad and the server just crashes. And maybe you've got something in place to get around that pretty quickly, or maybe you don't. But doing things to try to minimize the risk of that happening to you is part of what we're talking about today. A more common thing that happens is something goes wrong with your storage subsystem. So a drive fails or multiple drive fails, or you've got a RAID controller problem or a problem with your IO subsystem, a driver has a problem and your data gets corrupt or your data goes offline. So that happens fairly often, not as often as it used to, but by far the most common reason people have unplanned downtime is just human error. And that's one reason why it's harder to get your first DBA job. If you're a developer and you're writing code and the code doesn't compile or it throws errors while you're working on it, nobody sees that but you, typically, unless you check it in that way. But anyways, if you're a production DBA and you make one little mistake and you accidentally drop a table because you thought you were connected to development, but you're connected to production, people tend to notice that, right? And that can cause an outage. And that's a thing that happens so often. It's so easy to make a little mistake and your blood just runs cold. Oh, what did I just do? So that's the most common reason for unplanned downtime. And there's things you can do to try to mitigate against that happening besides just being careful, which you should always be as a DBA. So planning an HA strategy, what so many people do, which is a mistake, is they just say, okay, availability groups are the new thing that everybody should use. So let's do that. Even though we have no experience with availability groups or even database mirroring, let's just do that, whether it works for us or not. And that's the wrong way to do it. What you need to do is talk to the business and find out and talk to them about what's called a recovery point objective, RPO. You also need to talk to them about recovery time objective, RTO. And what these two things mean is RPO is how much data can you afford to lose before it's a big deal for the business. That's sort of the common language way of describing it. Of course, if you ask the business that, what are they going to say? They're going to say none. We can't afford to lose any data or it'll be the end of the world, right? And so you need to kind of push back on that and say, okay, well, that's really hard to achieve in real life. And if you try to get as close as possible to it, it's going to be pretty expensive. So let me put together a plan and a budget for how we could try to get as close to zero as possible. And let's talk next week about it, right? So then usually when you do that and you have your meeting and they see how much it costs to do that, quite often they'll say, hey, wait a minute, we can't spend that kind of money. So they'll back off a little bit and say, okay, maybe 5 minutes is okay. But the point is, you've got to go through this exercise because otherwise they're going to assume that your RPO is zero because, hey, Glenn Berry, he's our DBA and it's SQL Server. How could we lose any data? And that's not true. And seriously, you need to go through this exercise and get them to agree that, okay, 5 minutes or 10 minutes, whatever it is. And then you try to build your infrastructure and all your policies to meet that RPO goal. And then the other one, RTO, is if something bad happens, thank you, Alexa. So anyways, if something bad happens, how long does it take you to recover from that? So if you lose a server, do you have a replacement server just sitting there or do you have to order one from Dell? Do you have another thing you can fail over to? So what you need to try to do is come up with, what do you think are the most common bad things that might happen? And then figure out, how long would it take me to recover from that? If I dropped a table on production, how long would it take me to recover from that? And you come up with a list of, here's the most likely failures and here's how long it would take to recover, and then talk to the business. Is that okay? If we're down for an hour in the middle of the day, is that okay or not? And you need to come to an agreement so that you have something you're trying to meet. So that's really important that you do this. And then once you have RPO and RTO, then you can decide what technologies to use. So here's something that's really important. A lot of times you hear people talk about 5 nines availability or 4 nines availability, and this chart explains what that means. And so it's pretty easy to meet, say 99%, that's 2 nines availability. That means you can be down for 3.5 days roughly per year. That's a long time. And even with a standalone instance of SQL Server with no HA whatsoever, you can probably meet that unless lots of bad things happen to you. But as you go further down this chart and get to 3 nines and 4 nines, it gets a lot harder. So with 4 nines, you're only allowed 52 minutes per year of downtime. And if you have a standalone server that's on bare metal, just bouncing the server one time might take 10 or 15 minutes for it to come back. So it's really easy to burn through 52 minutes of downtime. And if you're being judged on this, it's important whether or not this is total downtime or just unplanned downtime. But this, as you go further down and people talk about 5 nines and 6 nines availability, it gets really hard to meet with SQL Server. So here's some of the SQL Server 2019 HA related technologies that you have to work with. And the first two aren't really technologies, they're just more things you should do to make sure you have a better HADR story. So backup and restore methods, I'm going to talk about that. That's extremely important that you have a good backup and restore strategy, because if everything else fails, as long as you have a good set of backups that you can restore, you can eventually come back online. But if you don't have good backups, then it's game over and you're going to get fired and your company might go out of business, seriously. So that's the most important thing by far. And then component redundancy is a very important. And then we'll go through all the other things: Windows failover clustering, availability groups, database mirroring, transactional replication, which a lot of people don't think of as an HA technology, but it can be used for that. And then log shipping, and then database snapshots. So backup and restore methods. SQL Server databases have 3 different recovery models you can use. So you have full and bulk logged and simple. And for most HA technologies from SQL Server, you got to use the full recovery model at all times. Not all of them, but many of them require that. And some people have a habit of, hey, let's switch to bulk logged in the middle of the night when we're loading a bunch of data and switch back to full. And you're not going to be able to do that with some of these technologies. And if you're running in simple recovery model, you have a pretty bad RPO story, because all you can do is restore to your last full or differential backup. And you're going to lose a lot of data potentially depending on when your failure happened. So you need to have a backup strategy that lets you meet your RPO. So you need to decide, how often are you going to take full backups and what time of the day are you going to take them and how long does it take to them to complete. And then a lot of people don't even use differential backups, and they can be really handy because it gets everything since the last full or last differential, and it lets you skip a lot of log backups if you're trying to restore everything if you have a differential. So it helps you shut down, or shorten, I should say, your RTO window. And then log backups, that's really important, because if you've agreed with the business that you have a 15-minute RPO, that means you should be taking log backups at least every 15 minutes. Otherwise, unless you get really lucky, if you're taking log backups once an hour and you have a 15-minute RPO, it's very likely, unless you can take a tail of the log backup, that you might lose more than 15 minutes of data. So that's why you need to have that RPO right up front. And then using backup compression, usually that's a good idea in most cases, unless you have extremely fast storage where it can actually slow you down. Using backup checksums is very important to make sure, or help make sure, I should say, that your backups are actually good. And then using some of the backup tuning options, things like this will make your backups and your restores go more quickly, which helps you in an HADR scenario. And then you actually have to recovery strategy. So you need to test restoring your backups. Very few people actually do that. And so they run in backups and then something bad happens and they go to restore from their backups and it doesn't work. Oh no. And then you try the older one and it doesn't work. And then you start getting really desperate and that's a bad story. And so using things like instant file initialization and having backup compression can help reduce your restore times. And also keeping your VLF counts low reduces your restore time. So if you ever watched a backup going, or actually I should say, if you've ever watched a restore running in Management Studio and it says 99% done and 100% done, and you say, okay, great, it's done. And then it keeps on grinding for another 10 minutes. That's because it's going through the recovery portion of the restore. And if you have really high VLF counts, that's going to take a lot longer. So here's some of the back that I mentioned. Buffer count and block size and max transfer size are optional parameters you can use with your backup command that, depending on your infrastructure and depending on your data, can make a huge difference in how long it takes for the backup to run. And if you've got really large databases and you're worried about, hey, it takes 8 hours to back up this database, and that makes life hard for me, sometimes playing with these commands can make a big difference. And also using striped backups like I have in this example, where you're splitting the backup into multiple backup files, can make a big difference depending on the storage. So that's important. And if you're using transparent database encryption, it used to be that backup compression did not play well with transparent database encryption. And then SQL Server 2016, they made them play well together, but you had to use max transfer size greater than 64K or else they wouldn't. And now in SQL Server 2019 CU5, they removed that requirement. So that's nice if you're on 2019. So below is an example of a backup command using these parameters. And those numbers that I have here are not going to work for everybody. You need to try it out on your big databases that you're worried about. So another thing you should try to get in the habit of doing is using a secondary restore server. So after you run a backup, you can have something automated. So after the backup finishes, you try to restore it on a different server on a nightly basis, for example, and then run dbcc check db on it after you restore it. And then if it fails there, then you can run it again on the live production server to see if you have the same problem. But the point here is a lot of people take the backups, but they don't restore them. And that's the only way to know for sure that your backup is good by restoring it. So that's something I think you should try to do if possible. I've got a lot of clients who do that. So Bill Baker was a distinguished engineer at Microsoft, and he came up with this idea that I sort of changed a little bit, but it's a good way to think about the difference between database servers and, say, web servers or application servers. So typically with database servers, as you get more load, you scale up. So you go from a 2-socket server to a 4-socket server, for example, and your database server is a mission critical asset. And so you think of your database server like a pet, and you give it a name. And when your pet gets sick, I've got a couple puppies, when they get sick, you rush them to the vet and you pay whatever it takes to nurse them back to health. So you take really good care of your pets. And that's like a database server. Now, web servers, you can have lots and lots of web servers, and it's very easy to scale them out behind a load balancer. And so usually web servers are more like cattle. They don't get names. They just have a number and an ear tag probably. And when they get sick, you just shoot them. You don't even take them to the vet. And that's a little harsh, but that's Bill Baker came up with this idea, so blame him, not me. But the point is, people will often push back and say, hey, you don't need redundant components. That's extra money we don't ever have to spend. That's not true for database servers, because if you have an outage because a $100 part failed on your database server and you're down for an hour, how much business did you lose, or how many customers did you upset by having that failure, by not spending that extra money? So component redundancy, that leads into that. You want to have redundant components for your database servers, and modern PC-based servers have lots of redundant components that you can use if you want to. So you can have things like hot swap hard drives or SSDs. You have hot swap power supplies. You can have multiple power supplies plugged into different circuits. So you need to actually think about this. And maybe, a lot of people aren't really into hardware very much, but if you're the DBA, talk to your server people and make sure that they're actually doing this, and go to the data center if you can and look at it, because it's so easy to do dumb things. Like you get a database server with two power supplies, but they're both plugged into the same PDU in the rack. So if the PDU goes down, the server goes down anyways, even though you had two power supplies. Because the idea here is you're trying to avoid any single point of failure. So if one little commodity part that costs $100 fails, you don't want your expensive database server that's running your business to crash in the middle of the day with no warning. So also involved with this, you want to make sure that you have got an appropriate level of RAID for all your storage, and using hot swappable components is a good idea, and also some cold spares. So if you standardize on one model server, like a Dell PowerEdge R740, maybe you have one extra power supply that fits that model server as a cold spare. So if you lose one, you can immediately replace it with your cold spare, and then have Dell get you your replacement in the 4-hour window that they guarantee you to get your replacement in, for example. All right, so component redundancy versus HADR. All these HA technologies I'm going to talk about have failover time. So with a traditional failover cluster instance, you have to move the cluster resources from one node to another and then start SQL Server on the new node. So you're going to be down for maybe 60 or 90 seconds. And if that happens just because you lost a power supply, that's bad. And so having that component redundancy helps you avoid having a failover because of a hardware failure. And availability groups and database mirroring, they fail over more quickly, but they still take some time to fail over. And if you're using log shipping, that's more of a manual process. So you're going to have downtime because of your hardware, and you want to try to avoid that. It's pretty inexpensive. But again, in my experience, people will push back and say, oh no, let's not spend that money. So you need to fight that fight if you're the DBA. All right, HADR effects on your hardware choices. You need to think about, does your HADR architecture put any extra workload on your system? And it depends on what technology you're using. So if you're using failover cluster instances or log shipping, there's no extra load, because you're already taking transaction log backups if you're in full recovery model, and that's the only extra thing from log shipping. And failover clustering doesn't have any extra load. But if you're using availability groups or database mirroring or transactional replication, they all create a little bit of extra workload because of what they're doing to maintain that extra copy of the data somewhere else. And that puts more load on your infrastructure. You also need to make sure that if you're using something like availability groups, you're typically running on one node most of the time, and then you have secondary replicas. Ideally, you want the hardware to be identical, but what a lot of people end up doing is they use older or slower hardware for their secondaries. And you want to make sure that the secondary can keep up with the primary, especially if you're doing synchronous replicas. Otherwise, it's going to cause slowdowns for your application just during normal usage, and the users aren't going to like that. And then you also want to understand, if you have to fail over, can you actually run your workload on the secondary, or is it going to be really struggling? So these are things you need to think about as you're just deciding how to set up your architecture. All right, the final thing about this is your effect from HADR on your storage choices. So if you're going to use failover cluster instances, you have to have some form of shared storage. And that usually means a SAN. But you can also use storage spaces direct, or you can use third-party products like Sios to make that work. But that's something that's going to force you to have shared storage. And if you are using a SAN, which I don't like SANs to be quite honest, but if you are using a SAN, one thing you can do to really improve performance if you need to is move tempdb off of the SAN onto your local nodes and have it on very fast flash storage, or ideally on Intel Optane storage. And that can make your tempdb go a lot faster. And also it takes the tempdb load off of the SAN. So that's something to think about. And any other thing you might be doing, like database mirroring or availability groups or log shipping, can use any kind of storage that you want. So don't let anybody push you into using a SAN unless you have no other choice. because you can get better performance for less money if you don't use a SAN. And if you are a SAN shop, you want to try to make sure that you're not using one SAN for both sides of your HA architecture. Because then if the SAN fails, which is possible, despite what the salespeople might say, then you're in a bad situation. And that actually happened to me at NewsGator, where we had a really expensive 3-par SAN that the salespeople had guaranteed, this thing will never go down. It's got quadruple redundancy everywhere. Well, it turned out that it had a bug in the operating system. And so we had a failover cluster instance on the 3-par SAN, and then we had database mirroring to another SAN. And so this thing was bouncing around on the failover cluster instance, and we were able to fail over using mirroring to the other SAN and come back up after a few minutes. And that saved the day. So don't trust SAN salespeople is the moral of that story. So anyways, the final thing about storage is RAID levels. RAID is a redundant array of inexpensive disks. And RAID is not a substitute for a good backup and restore plan, no matter what anybody tries to tell you. I once had a CTO try to tell me that, hey, you're using RAID 5 for your storage for our SQL Server database, so we don't need backups anymore because RAID 5 will protect us. No, RAID 5 is not very robust. And it doesn't matter what level of RAID you have, all that does is protect you from going down, from losing a certain number of drives in the array. So don't let anybody push you into not doing backups. I don't care what kind of fancy appliance they're using. You want to do your SQL Server backups, and then don't give up on that fight. And then RAID's not a substitute for an HADR strategy. Don't let people talk you into that. Oh, we're using this fancy RAID level and this storage appliance, so we don't need to do anything like database mirroring or availability groups because that'll take care of us. I don't trust that as a DBA. I want to use the native SQL Server technologies as much as possible for my HA and DR. And then if you are talking about RAID, RAID 10 and RAID 50 are more resilient and robust than RAID 5. RAID 5 only lets you use one drive in the array. And if you lose a second drive, it's game over. That array goes down. And if you have a RAID 5 array with lots and lots of drives in it, the statistical chance of any one of those going down increases. So RAID 5 is not good for HA. You want to try to use RAID 10 or RAID 50 if possible. And again, having some hot spares in the enclosure or having some cold spares is a good idea, so you don't worry about going down because of losing drives. All right, now we finally get to the clustering choices, or the HA choices, I should say. So Windows failover clustering has been around for a long time, and many IT people are familiar with it because they've used it for other products. Well, it works with SQL Server too. And you have a Windows failover cluster to start with, and then you install it as a SQL Server failover cluster, which is different from a normal SQL Server standalone installation. And you've got multiple nodes in your cluster and one or more instances of SQL Server on that cluster. And this requires shared storage, like I said before, which is a single point of failure. It doesn't happen very often, but it can happen. And you can use other things besides a SAN for that shared storage, like I mentioned before. And this gives you instance level high availability, which is really nice, because let's say you've got 100 databases that you want to run on your instance and you add 20 more. Well, as soon as you add them to the instance, they're automatically protected by failover clustering. You don't have to do anything. You don't have to set them up in an availability group or with log shipping. They're just automatically added. Plus, it automatically protects your system databases and your logins and your agent jobs and linked servers. Everything that you set up in that instance is protected by the cluster. So this is great for a lot of shops that don't have a dedicated DBA. Once they set the failover cluster up, it just sort of takes care of itself. And the downside to failover clustering is the failover time is longer, because again, you've got to move the cluster resources to another machine and then start SQL Server on that machine. And that whole process typically takes 60 to 90 seconds, but it can take a lot longer if you've got lots of databases and they all have high VLF counts. So that's another reason you want to keep your VLF counts low, so that when you start up SQL Server, all the databases have to go through crash recovery, and it takes a lot longer with high VLF counts. So that's failover clustering. And here's a little picture of what it looks like. This is a very simple, bare minimum failover cluster architecture. So you have two machines that are called nodes, and you install one copy, one instance of SQL Server on this clustered instance. And then only one node owns the storage and is running SQL Server, and the other node sitting there doing nothing. And people used to call this an active passive. If you say that nowadays, people out there like Alan Hurt will get very upset with you. Oh no, don't say that. That's the wrong terminology. But anyways, this is two nodes in one instance, and only one is doing any work and the other sitting there doing nothing. So a lot of times your management doesn't like that. So what they'll push you into doing is installing a second instance of SQL Server. So then you have one instance running on each node. And then what can happen is you can have both of them running on one node, both instances. And you want to make sure, if you're in that situation, that either node can run both instances of SQL Server. It's got enough CPU and enough memory to run the entire thing in a worst case scenario. So, this is old fashioned and it has some drawbacks, but it's a great solution for a lot of people because it's so easy to maintain going forward after you get it set up. All right, so I already mentioned this, but with SQL Server 2012 and newer and failover cluster instances, you have the option of moving tempdb off of the shared storage to local storage. And if you're using Intel Optane storage for local storage, it'll absolutely smoke any SAN in existence for performance because the latency will be lower, it's local, and Optane storage is usually faster than anything a SAN is going to have. So it makes you have better tempdb performance, and it takes that tempdb load off of your shared storage. But usually when I pitch this idea, the infrastructure team at a client was, oh no, we can't do that. And they give you all the reasons they don't want to do that. But this is an easy solution that doesn't cost that much money. And I don't work for Intel. In fact, a lot of people say I hate Intel, but Intel Optane storage is really good. And this specific product has been out for several years now. It's called the Optane SSD DCP4800X. It's a great product. It's an add-in card that fits in a PCIe slot, and it's amazing. It's not flash storage. It's actually something different that uses phase change memory. So the latency is a lot lower. And so here's a little bit more information about that. It fits in a PCIe expansion slot, and it needs to be PCIe 3.0 with 4 lanes, and it's NVMe storage. And there's 3 different capacities. The lowest capacity, 375 gigabytes, is about $1,000 for that. And that's more expensive than most flash storage, but it's amazing how much better it performs. The latency is an order of magnitude lower. The durability is higher. It gives you better random IO performance. So if you have a workload that's really hammering tempdb, this is a great solution. And that's what it looks like. So that's the end of the Intel commercial, but I've got a lot of clients that have used that, and it works really well. So moving along, this little chart lays out the HA features by edition. And there's different features on the left here, and Enterprise Edition of SQL Server has everything. Of course, you would assume that, right? And Standard Edition doesn't have some of these features that we'll be talking about. And they improved that situation in SQL Server 2016 SP1. But even with that, some things are not available in Standard Edition. If you're running Express Edition, virtually none of these are available. So that's one thing to keep in mind. Ideally, if I'm the DBA, I want Enterprise Edition for everything, but you don't always get that. So just be aware that Standard Edition has a few restrictions. So availability groups are a technology that was introduced in SQL Server 2012. So it's been around for a while. And this was sort of meant to replace database mirroring, and it hasn't completely done it yet. You can say it has because database mirroring is deprecated, but it's similar in some ways. And what an availability group does is it lets you have one or more databases that need to fail over together. So you've got an application that uses 2 or 3 databases, and they're all necessary for the application. And you want to make sure they fail over together. And that's what an availability group lets you do. And older versions of SQL Server, you had to install the failover cluster feature. I think you don't have to do that with 2017 and newer, but most people still do. If it doesn't require shared storage, and that's important because a lot of people think, oh, I got to install the failover cluster feature, so I'm going to need shared storage. And that's not true. You can use any kind of storage you want for availability group nodes. And all your databases with availability groups have to use full recovery model at all times. And any database that you want to be in the availability group belongs to that AG. And then the primary is the read-write copy, and you only get one of those. And then you can have multiple secondary databases running on different instances of SQL Server that are called secondary replicas. And they can be read-only or they can not be read-only, but they are not writable. And when I first heard about this feature way back in 2012, I was pretty excited because a lot of people will use transactional replication for reporting purposes. And you add extra indexes on your subscriber to make reporting queries run more quickly. And I was thinking, okay, we don't have to do that anymore. We can use this and use a read-only copy for reporting. You can do that. And Microsoft says, oh yeah, that's a good idea. You can do that. But the problem is you can't make any schema changes. You can't add any extra indexes to your read-only replicas. And so if you're doing that on purpose to make reporting queries run better, you're going to need to still use replication for that instead. So here's what an availability group sort of looks like. And in this picture, we've got 3 nodes and we have 3 instances of SQL Server, and they're all installed just like normal standalone instances. But then you have to go in and enable availability groups at the instance level, and then go and create the availability groups. And in this case, the primary, that SQL prod 1, is your read-write copy, and then the other 2 are secondaries, and they can be readable or they can not be readable. Excuse me, and they can be synchronous replicas or asynchronous replicas. And an important thing to keep in mind here is you have 3 copies of the data. So you're going to need disk space to have, an extra copy of the data. And with a failover cluster instance, you only have 1 copy of the data that lives on that shared storage. So if you've got multi-terabyte databases, this is something can come into play, having those extra copies of the data on the other replicas. So then if you have SQL Server Standard Edition, it used to be you couldn't use availability groups until SQL Server 2016. Now you can use what are called basic availability groups. And this lets you basically do the same thing you can do in database mirroring with a couple of minor changes, but it lets you create a basic availability group that has only 1 database. You can't have multiple databases in it, and you can only have 1 copy of it. So it's very similar to database mirroring. The big difference here is that with SQL Server Standard Edition database mirroring, you had to use synchronous replicas, or synchronous mirror, I should say. And now with this, you can pick between asynchronous or synchronous. And that's a big deal. If you have replicas that are not in the same data center, it's going to be hard to do synchronous replicas over large geographic differences because of the network latency. So anyways, basic availability groups, you get 1 replica and there's no read access on the secondary, and you can't take backups on the secondary like you can with regular availability groups. And there's only 1 database in the availability group. So if you've got 100 databases, you got to set up 100 basic availability groups, 1 for each database. And then if you decide later on, let's upgrade in place from SQL Server Standard Edition to Enterprise Edition, you're going to have to tear down all your basic availability groups and rebuild them. It doesn't let you upgrade them. And then you can only use these on Standard Edition, which makes sense. If I had Enterprise Edition, I wouldn't want this. I'd want regular availability groups. So database mirroring came out in SQL Server 2005, and it worked great. And I used it for many years, but it got deprecated in SQL Server 2012. And that doesn't mean that it doesn't work anymore. It just means that Microsoft discourages you from using it in the future. And it still works in SQL Server 2019, just like it always did. And it can be a good solution in some scenarios because it's easier to set up for people who don't have any experience with mirroring or availability groups. And that's a reason by itself. If you have a fairly novice DBA team, database mirroring is easier to handle than availability groups are, although they're not that difficult. But the point is, you shouldn't just say, oh, we should never use it because it's deprecated. If it makes sense, it still works. And it's not going to just suddenly stop working at some point in the future. Microsoft at one point was threatening on taking it out of the product, but they changed their mind, and it's probably never going to be taken out of the product. So anyways, the way this works is you have a principal database on one instance of SQL Server that's a read-write copy. And then you have a mirror database on a separate instance running on another machine. And what happens is, as you change the data in the principal, it gets sent over the network and gets replayed in real time on the mirror. And those should be in sync unless something bad is happening. And your database has to be in full recovery model at all times, just like with availability groups. And you can have synchronous mirroring, which means you do a two-phase commit. You change data on the principal, and that change is sent over to the mirror and played there, and then the acknowledgement comes back. So that extra work of sending it over and then committing it and acknowledge it, that adds some extra latency. And that can have a performance impact on your application, especially if your network is slow or if your storage is slow on the secondary, especially where the log file is. So you have synchronous, and that's required if you want automatic failover, or you can have asynchronous in Enterprise Edition, which means you change it on the principal and then you just send it and you don't wait for it to actually get committed. And with asynchronous mode, it's possible for the mirror and the principal to not be synchronized. You can have unsent data or unreplayed data. And that's bad because if you had to fail over in that condition, you could lose some data. So asynchronous is a little bit more dangerous. And it's usually used if you have slower hardware or storage, or if your mirror is far, far away and having the synchronous is too much performance hit. So that's kind of some of the different features of mirroring. And again, you only have one database with one mirror, and you can't access the mirror unless you take a snapshot of the mirror, which is not a good idea with database mirroring. But that was a feature that you could take a snapshot of the mirror and then run reports against the snapshot. But that doesn't perform very well in real life, and I wouldn't do it. So here's what database mirroring looks like. You've got a principal on one machine, and the data is there. It's got its local copy of the data, and that's your read-write copy. And then over on the right, you've got a mirror where that database is mirrored to, and there's another copy of the data there. And the witness is only needed if you want automatic failover. And the witness helps form a quorum. So if the principal can't talk to the mirror, it'll ask the witness, hey, can you talk to the mirror? Well, actually, I should reverse that. If the mirror can't talk to the principal, then the witness will also agree, hey, I can't see him either, so let's do an automatic failover from the principal to the mirror. That's how automatic failover works. And it's only required if you want automatic failover. So that's how database mirroring works. And it's not that difficult to set up. It's very similar. I should step back for a second. Availability groups and database mirroring and log shipping all have a similar issue where you've got your read-write primary or principal copy, as the case may be. And if you want to set up these technologies, you've got to take a full backup of that and then restore it somewhere else and then get the data synchronized. And so you have that similar issue with all of these technologies. And of course, you don't have that with clustering because there's only one copy. So transactional replication, that is something that you have a database that's your read-write copy, that's your publisher database. And you can go in and just replicate the entire database. A lot of people will do that. But what's more common is you decide, hey, we want to replicate these 5 tables to another server, and we run reports against those tables. And we're going to move that reporting workload off our main OLTP instance, which is the publisher, and then have this subscriber that has those 5 tables, and we add a bunch of indexes to those tables to make the reporting queries run more quickly. So that's sort of the common scenario. And if you do that, you've got to go in and tell SQL Server what tables you want to replicate, and you can filter by column and even by row. And then you typically create a snapshot, although you can initialize from a backup if you have a really large database. And Then what happens is you have a log reader agent that picks up all the DDL and DML changes to the data and then stores it in a distribution database, which might be local to the publisher, or it could be another instance, which requires more SQL Server licenses. And then you can either do a push or a pull subscription that is getting the data out of that distribution database and replaying it and synchronizing that subscriber. And if everything's running well, there's only typically a few seconds lag here, but if things are not running well, you can have a huge lag between the two. So again, this is mostly used for reporting purposes, but also can be used for HA. If you're replicating the entire database and then something terrible happens to your publisher, you can make the subscriber, you can bring it online and use it fairly quickly. It's not automatic, but you can script out the commands and make it happen fairly quickly. And the nice thing about replication is once you set it up with the publisher and the distribution database, you can have multiple subscribers. So you could use that for DR purposes. You could have a subscriber in a different data center and then move over to that if you had to. All right, so SQL Server 2017 had a bunch of improvements to replication because a lot of people sort of had the idea that, oh, replication is old and it doesn't work that well anyways, and Microsoft's abandoning it. That's not really true. And this is another reason why you want to try to stay up to date with your cumulative updates as much as possible, because what they did is in cumulative updates to SQL Server 2017, they added improvements to replication. So they made the distribution database take better care of itself, because that's a problem in many cases that it gets very large and it has trouble cleaning data out of it. And there's a lot of times you got to mess with that if you're a DBA. And they also made it, if you needed to change what's happening with one of your agents, like your log reader agent, you could do that without having to restart it. And then the final thing is that you can protect the distribution database in an availability group. And you couldn't do that before. So that's nice features they added after the release of 2017. So the final kind of replication is called peer-to-peer replication that we're going to talk about here. And this is database level protection typically. And where this is commonly used is a scenario. Let's say you've got 3 offices in your company, like one in Tokyo and one in New York and one in London. And you want to make it so that each one of those offices has their own writable copy of the database. And that's usually kind of hard to do with SQL Server. You only get one writable copy, but peer-to-peer replication lets you get around that, although it's not that easy to set up. But the point is, you set up these 3 databases in peer-to-peer replication, and then as the data changes in one copy, it gets sent around to the other 2, and they eventually, hopefully within a few seconds, synchronize up. And that works. It's usually used more for scalability, not as much for HA, but you get that as sort of a secondary bonus. And the problem with this, why it's hard to set up, is you might have to go in and make some changes to your application or to your database to make this work. A very common issue is if you use identity columns for an artificial key, like say employee ID, well, unless you set different ranges of identity columns values in the different copies, they're going to collide with each other, and that's not good. And you want to try to avoid using a GUID for that instead, but that's something you need to think about. And of course, this requires Enterprise Edition. It doesn't work with Standard Edition. And in my experience, not too many people are using peer-to-peer replication, but it is something that SQL Server offers. And then log shipping. Log shipping is another database level protection option. And it's usually used more for DR purposes instead of HA. But the nice thing about log shipping is you can have multiple copies of your database through log shipping in different locations. And once you set it up, it's easy to add more. And the databases have to be in full recovery model. And this is kind of a recurring theme here. And you have to do a manual failover if you want to go from your main copy to one of the other copies, although you can write some code with T-SQL to semi-automate this. And then some data loss is possible, because what log shipping is doing is it's automating the process of taking log backups. So with log shipping, you take a log backup and copy it somewhere else, and then you restore it to the destination. You have agent jobs that are doing those 3 steps. And if you're in full recovery model, you're already taking log backups. So you're just automating this and changing how it works a little bit to give you extra copies of your databases. And one really nice thing about log shipping, if you want, you can have a log ship copy of your main database that has a restore delay of say 4 hours. And what do you think that might be good for? What happens if one of your users or one of your developers, you know, runs an update statement with no where clause and they update every row in the table? And then they tell you immediately, which is you hope they do that. Well, if they've done that, you can go and get the data from the log ship copy that has the 4 hour delay before it gets stomped on by their mistake. And then you can use that to restore the production copy. And that might be a lot quicker than restoring a full backup and then getting the data out of that backup that you just restored. And then the other reason I like log shipping is, again, it doesn't add any extra performance overhead. And you can layer log shipping on top of other things. So you can have a failover cluster in your main data center and then log ship to your disaster recovery data center. And you can have another log ship copy with a 4 hour delay to protect against user error. So, you know, you can get creative here and come up with a plan that gives you a lot better total story. So here's what log shipping looks like. And the primary is your read-write copy, and it's a full copy of the data on your main server. And then you can have multiple secondary servers that have another copy of that database. And what's happening, and the reason why you could lose some data is you're taking that log backup, say every 15 minutes, and then you're copying it over someplace else, and then you're restoring it. And if you lost your main server before the log backup finished, or before it got copied off, or before it got restored, there's lots of ways you could lose some data since your last log backup that got restored to that secondary server that you're trying to move over to. So again, this is a better DR technology than it is for HA, but it's better than nothing for HA. If you just have a standalone server and you want to dip your toes into having some HA, log shipping is really easy to set up and play with. So database snapshots are another sort of HA technology. And what it does is it just takes a pointer of what the data looks like right now when you create the snapshot, and then it tracks the changes that happen to it over time. So you don't want to create a database snapshot and just leave it there for a month or two, because then that snapshot fire is going to get really big and start having performance issues. And why you might want to have a database snapshot, where I've seen people use them, is let's say that you're getting ready to push out a whole bunch of changes to your database. Some shops will take a snapshot of the database before they do it. And then if the changes they push out just don't work, even though they were tested, you could revert back to the snapshot. Another reason people will do it is they might take a snapshot at midnight and then point reports at the snapshot so they can see what the data looked like at midnight. So those are some of the common scenarios for snapshots. Snapshots used to be only available in Enterprise Edition, but they were added to Standard Edition in 2016 SP1. So they are available. So here's some of the feature differences. This chart's kind of handy. If you look at these different features, failover clustering is an instance level protection. So that's what the scope means. And you can use any recovery model you want. So if you want to use simple recovery model, or if you want to be able to switch to bulk logged when you want to, failover clustering lets you do that. Now the downside is that the failover time is relatively slow with failover clustering. Availability groups protect databases, and they can be multiple databases together, and you have to use full recovery model, and the failover time is fast. And then you can see that for the rest of them, almost all the other ones, they're database level protection. They don't give you instance level protection, just database. And transactional replication can drill down and just protect individual objects like tables. And transactional replication also lets you use any recovery model you want. So if you don't want to use failover clustering because you don't want to use shared storage, you could use transactional replication instead. And then you could use whatever recovery model you wanted to for your databases. And then you don't get automatic failover with transactional replication or log shipping. So this chart is a fairly easy reference to the major differences between these different features. All right, so planning a disaster recovery strategy. This is really important. Yes?
We have 6 minutes left. We don't have a lot of questions.
Oh, wow.
We only have 2 questions.
Because I've got 33 minutes left, I think. I think I go for
Oh, is it
90
an hour
minutes.
and a half?
Yeah.
I thought it was...
Yeah, he's got an hour and a half. So 30.
I'm wrong. Yay. Okay. I was like,
Yeah, I knew
oh
I wasn't
no.
that far behind.
It's the best way to
Oh,
be wrong, though, I think, when it's extra 30 minutes on our side. So that's awesome.
okay, good. I was wrong. I'm used to these like
No worries at
1
all.
hour ones.
Yeah, I'm not that far behind.
Was the first
So
session just an hour?
no, it was 9. They're all 90 minutes, but he just
Oh.
ran right up to the limit.
Q&A, hangout, bio breaks, all that good stuff.
Okay. What time do you want me to let you know? Like, do you want me to tell you when we've got 10 minutes left then?
How about 5 minutes? And I've got a
5?
timer
Okay.
going here, so I'm kind of
Oh,
keeping an eye on it.
you don't need me too much. Okay.
All right, so
All
let me
right.
get back into this.
Okay, sorry.
That's all right. Thank you. So the point here is that you need to plan your disaster recovery strategy. And the point is that no matter what kind of HADR you have in place, things can go wrong. And the main point, if you don't remember anything else from this entire presentation, good database backups are your last line of defense. If you've got backups that you can restore, you can eventually come back online and your business can eventually come back online. But if you don't have that, it's just game over. And I've seen multiple small and medium-sized companies have that issue where they didn't have any backups and something terrible happened to their live copy. They thought they had backups, but the backups weren't any good. And then it's update your resume time. And the company may even go out of business if that happens. It's really serious. So anyways, a good disaster recovery plan, your senior people should be writing it, but it should be tested by your junior people and maybe a non-DBA, because usually they're the ones who are on duty or on call late at night or on the weekend or on a holiday period. And you want to try to make it so that it doesn't have to be a DBA to be able to follow it. It should be maybe a system admin or a QA person. Whoever's available should be able to read your disaster recovery plan and all the scripts and everything that you have ready and follow it. And it needs to be comprehensive and detailed. You can't just say, restore the database from backups. That's not going to be good enough, even for a DBA. Where are the backups stored? And where the live database is located. I need to know that. So when I restore, I might have to use the move command to make sure everything goes where it needs to go, or I have enough disk space, for example. So it needs to be very detailed. And then you need to have some information there. What happens if you try to restore the database and you get an error? What do? Call Glenn? Or do you have some information in there? Here's what you can do to troubleshoot if this restore command doesn't work. And if it turns out that it just doesn't work, here's where the next set of backups would be. And here's the naming standard for how our backups are named. So go back to the next oldest one, for example. And your disaster recovery plan needs to consider human factors. So if there's a hurricane coming into Florida, do you think your employees are more worried about keeping your website running? Or are they more worried about keeping their family and their house safe? And so some companies who have locations where they're prone to hurricanes, for example, they will have a secondary data center far inland. And when a hurricane is coming in, they'll go and get their key staff and their families and put them on a plane, or maybe now put them on a train or a bus, but take them to the secondary data center and put them in a hotel. So then your people can concentrate on their job and not worry about their family because they know that they're safe. And your disaster recovery plan should be tested. And then every time you try to test it, you're going to find, oh, we forgot about that, or we didn't have that information in there. So then you improve it. We didn't have the information about where the software license key was, or we didn't have some other information that we needed to try to execute this plan. And so you add it to the plan, and the plan gets better over time. And another way you can improve your disaster recovery plan is if you patch your servers regularly, like I think you should, you apply cumulative updates like you should, in my opinion. Well, if you have an HA technology in place, like availability groups, and you do that rolling update strategy, well, you're going to be failing over. And that's going to be part of your plan for disaster recovery in HA. And the very first time you do it, you're probably going to be nervous. Oh, is this going to work? When we fail over, are the applications going to come online? You'll have sweaty palms the first time. But after you do it every 2 or 3 months to apply CUs, pretty soon it'll be second nature. Like, oh yeah, we know how this works and we know we got to do this and this to make it work. So you have confidence in it and you're not afraid to touch it. So more DR planning considerations, you need to consider possible problems you might run into at each step and think about, okay, what happens? So if something happened like your data center got flooded and some of your servers are damaged by water, what would you do? Do you have any spare servers? Can you order a server from Dell or go to Micro Center and buy a server and get it into the data center? And so try to anticipate what might go wrong and think about in advance, what would you do if that bad thing went wrong? What if the SAN is damaged? What would you do? What if there's no power in the data center? Can you go get a generator or can you move to some other location temporarily? Maybe your data center is down, but you could move some servers someplace else and that has power. What if there's no data center at all? It got hit by an asteroid or something, right? But seriously, try to think about what you think is most likely to happen and write stuff in your plan to cover that. And a big one you really want to talk about is what if Glenn, the DBA, he's on vacation somewhere and he's out of contact and we have a disaster. Does anybody else have any clue on what needs to be done to restore all these databases and get everything working? You know, you want to try to think about that. And the better the plan is, the more likely that somebody else can actually follow it. So more people issues you need to think about, because seriously, the people issues are usually harder than the technology issues here. So if something is going wrong, who gets notified? And you need to have a policy in place. If you've got, let's say you've got 2 data centers and you're normally running in your nice fancy new data center and you've got a DR data center, and then your application starts having problems. How long do you spend troubleshooting it before you decide to fail over to the other data center? And this needs to be decided on in advance, because if you spend an hour troubleshooting and then the business is down for an hour, they might get upset with you. Hey, wait a minute, we spent all this money on the secondary data center. You should have just failed over after 5 minutes. They'll say that after the fact. And you need to have a policy in place that, okay, we'll spend 5 to 10 minutes maximum troubleshooting. And if we can't fix it in 5 to 10 minutes, fail over. And then there should be somebody who's in charge of making that call. It shouldn't be Glenn, the DBA. It should be somebody above you probably that says, okay, we've been troubleshooting for 10 minutes and we've been down for 10 minutes. Let's fail over and I'm calling it. And there needs to be somebody who's kind of driving that. And you know, if you've worked anywhere, usually there's people who have titles and there's people who are really in charge sometimes. But the point is somebody who has the horsepower and the respect to make it happen and people will obey that. It's important that you identify who that is. And then as you're dealing with this, who needs to be kept informed? Because usually what's going to happen is the business will be screaming, what happened? What happened? How long till we're back up online? And your boss will be looking over your shoulder and her boss will be looking over your shoulder. And it's a very stressful situation. So there needs to be some things thought of in advance. Okay, if we're having problems, we send an email out to this distribution list and tell them what's happening. And then we have somebody, not the DBA, who's busy, heads down trying to fix it, but somebody else who's dealing with all the requests for information. And I remember one time at NewsGator, we had a problem. We were down for a while and everybody in the company was coming to my cube asking me, what was going on? Can I help? What's going on? So finally, my boss took a whiteboard on wheels and he put it in front of my cube and he says, Glenn knows there's a problem. Please leave him alone. And that kept people from bugging me so I could concentrate on the problem. But something as simple as that can be helpful. And then you need to think about what other teams in your company need to be involved. So depending on what happened, you might have to have network people and infrastructure people and application people, and maybe some business experts, because after you fail over to your secondary data center or after you recover from whatever disaster, you can probably, if you're the DBA, you probably know how to log into your application and do some very light, what I call smoke testing. Oh yeah, it seems like it works. I think we're okay. But then what you might find out is that some little piece of it that you're not really aware of doesn't work. So then Sally in accounting tells you the next day, hey, payroll doesn't work because you didn't bring us back all the way online. So you need to have enough people who know how to test everything and say that, yes, everything is working, or else you're going to have complaints and you're going to be the one that gets blamed. So HADR testing, what you want to try to do after you set up your architecture is test it as best you can before you go on production. So do things like go up to your database server and just pull out a hard drive or unplug the entire server or unplug a network cable and see what happens. Does it initiate an automatic failover, or you just go offline and throw a lot of error messages? Try, and again, this is before you go live, but drop a table or truncated table and see what happens and how long does it take to fix it. And this sort of testing is sometimes called chaos monkey testing. And what we used to do when I worked at Avalara is we would periodically go grab a receptionist or somebody from HR who wasn't necessarily very technical from the office and take them into the data center and say, okay, just go unplug something or flip a switch, do whatever you want. And that was very effective, because if you're the network person and you tell them to do that, they'll say, wait, I better not unplug that cable because that'll break everything. But this non-technical person doesn't have that mental block, and then they'll help you uncover things you didn't otherwise think of. And then you also want to test, how long does it take you to install SQL Server? How long does it take to create a container or a VM? How long does it take to do a full restore of your biggest database? You should know that for your really large databases, because believe me, if you have to do a full restore and you're down for several hours, how often are your bosses going to be asking you, when's it going to be done? When's it going to be done? And you should have an idea how long it typically takes because you've tried it before. So it turns out after you've done all this, building and testing, and you've agreed, okay, we can be back online in 8 hours, no matter what. And so you try in a test and it turns out it takes you 10 hours or 12 hours. Well, you need to make sure the business knows that. It says, hey, even though we agreed we could do it in 8 hours, we can't quite do it because the database is too big, or our storage is too slow, or it takes too long to get the backups out of the backup appliance. So you want to make sure they know, so then you can hopefully get more resources or think of a better way of doing it, so they're not surprised when you don't meet it in real life. And then the hardest thing to do, which hardly anybody does, some bigger companies that are really, really serious about this, they'll just do unplanned disasters in production. And so they'll just say, hey, wait a minute. They'll walk into your cube or your office and say, we just lost the primary data center, go. And they hit a stopwatch. And then they see how long it takes you to recover from that. And they'll actually do something to cause it to fail. It's not a simulation, it's for real. And they see how long it takes you and whether it actually works. And that's pretty stressful. But if you've gone through that, then all the rest of this is fairly easy. So just to sort of summarize this, HADR is a lot more than just using your favorite technology or feature. And it's extremely important to have an RPO and RTO that's been explicitly agreed to by the business that you're trying to meet, because otherwise you're just guessing. And the business is going to assume that your RPO is 0, and they're going to assume that your RTO is like 5 minutes. No matter what happens, we can be back online in 5 minutes through just some magic. And you need to make sure that both you and the business understand your budget and infrastructure limitations. So it may be that they want a secondary data center, but they give you a budget of $10,000, set up a secondary data center. Well, that's just not realistic. And then you want to make sure that you've got good backup and restores, that you actually test the restores no matter what else you do. That's so important. I've stressed that over and over again. And make sure that your backups are good by actually restoring them. That's the only way to really know for sure. All these things you can do, like using checksums in your backups and do a restore, verify only, that doesn't tell you for sure if the backup is actually good. The only way you know is to actually run the restore and have it complete and the database comes online. And a lot of people don't do that very often, but it's a really good idea to try to automate that so it's just happening all the time. And then if it doesn't work, you know about it now instead of finding out in a real crisis, and you find out that your backups are no good and you're done. And then finally, keep in mind that you don't have to pick one of these things. Almost all these technologies can be layered. So you could have an availability group for local HA, and you could log ship somewhere else, for example, for DR. So there's lots of ways of making this more robust. So I've got some references here. All these links are Pluralsight courses, the top 3, I should say, that I've done. So one's about log shipping, one's on database mirroring, another one's on how to install and configure SQL Server 2016 properly. And then the bottom link is an old white paper that covers all these things except for availability groups really well, just sort of a foundational level. So that's it in English and German. Finished a couple minutes early. So do we have some questions? It looks like I see.
Yes, we do. Let me put my camera back on. Okay, so let's see here. We had, going from the beginning, JD Walker, and he had a few questions actually. The first one he said was, can you use SQL Server Express for a restore server?
That's a good question. One issue with Express is there's a limit to the database size you can use. So unless your databases were really small, I don't think that would work. But besides that, it probably would. I mean, the other problem with Express is it's limited to how many cores and how much memory it would use. But I think the main problem is just the database. I believe it's only 10 gigabytes. So if you had any kind of a decent sized database, that wouldn't work.
Now, what if somebody, I'm going to throw this in here, Glenn, what if somebody they weren't using it for reporting, they weren't using it for connecting, and they were looking at the different options, log shipping, availability groups, mirroring, replication, if they wanted to use developer edition and just never have anybody connect to that, in which cases would developer edition actually work and which would it not work?
Well, it would always work, but the
Well,
question is whether it's
legally.
legally. Yeah, I mean, that's the question. I mean, personally, I think you could use Developer Edition for some other things, but I don't think Microsoft would agree, to be honest. And even for that restore server that I was talking about, personally, I think that would be okay, but I don't think Microsoft would agree, unfortunately. And they've made it a little bit easier to use some of the HA stuff. In 2019, they made some licensing changes, but I think for the most part, they still want you to license the secondary for a lot of this stuff. But again, to really know the answer, you need to get in writing from Microsoft. It doesn't matter what I say or what somebody says. It needs to be in writing if you really want to rely on it. So, I mean, typically the way they would talk about it is if you weren't running a production load against it, if it was just there for HA purposes and you weren't running reports, then you didn't have to license it. But then sometimes I've heard counter arguments, and I just don't want to say, oh yeah, that's fine, because you might get in some hot water if you don't do it correctly according to Microsoft, unfortunately.
Okay. So here's another question. I'm going to pull them out a little bit out of order. From Kristen Hansen. I'm going to sneeze here. Woo. If a database snapshot is used for reporting services, can indexes be added to that snapshot?
No. Yeah, the snapshot, all it is just a point in time of what the database looked like when you created the snapshot. And the snapshot file is really small to begin with. And then it tracks all the changes that are happening in the live copy. But you can't make any changes to the snapshot. That's kind of the point. You want it to be the way it was when you created the snapshot. And it doesn't let you add indexes or anything like that to it.
Okay. So here's a question from JD Walker. In each environment for which I'm responsible, I have a WSFC with an instance on each and AG set up. Can I stack an instance on one of the secondary replicas to restore testing? Will that put an undue stress on my cluster, yes or no?
That would probably depend on your workload, I would say. But other than that, I don't see why that wouldn't work. I mean, I don't really like to mix failover cluster instances and availability groups if I can avoid it. I mean, it works, but it just adds extra layers of complexity. But if that's what you've already got, yeah, you could do that. I mean, because usually the secondary replicas aren't working that hard. All they're doing is seeing all the data coming in and then replaying it, and they're not actually running a normal workload. So yeah, just as far as what the machine is doing, that would work.
Okay. Next is another, actually, this is a question by Mikhail Oskin. What editions of SQL Server can we use to offload DBCC CheckDB and check our backups? And somebody had made the comment over here, you can't even use Developer Edition to do that. So
Yeah, legally you can't. Well, the thing is, DBCC CheckDB only runs with one thread on Standard Edition, so it can take a lot longer on Standard Edition. But so to be legal, you're supposed to be either running Standard Edition or Enterprise Edition, ideally the same edition as you're running in production. But for licensing purposes, it'd be a lot cheaper to use Standard. Just be aware that it'll probably take longer unless storage is your bottleneck, because DBCC CheckDB is really hard on your storage, reading the entire database in and checking it. And just having one core doing that, it's going to usually make it take longer. And that's what would happen with Standard Edition.
okay. Kristen just asked a question. Let's see if I understand this question. We are changing controllers to paravirtual from LSI. When we did it on a secondary node, we were unable to fail over in order to make the controller change on the new secondary. Is the failover not working because the underlying controller configuration is different?
That shouldn't be the problem. I mean, failover with availability groups usually is tied more to network connectivity and whether or not the data is in sync close enough. And something that low level with a VM and using the paravirtual controller, I don't think would cause it not to fail over. It would cause other problems, probably more from a performance point of view, but that doesn't make sense to me that that's why it's not failing over.
Okay. JD has another question. Am I misunderstanding failover cluster instances? I thought FCIs were sharing the same instance, and if you put separate instances on a Windows Server failover cluster in order to set up AGs, it wasn't an FCI. And then he said, on each node, I mean.
Okay, well, let me step back. I mean, the simplest example is 2 nodes, and you install one instance of SQL Server on that cluster, and it's only running on one node, and that used to be called active passive, right? And then what I think he's talking about is you install a second instance, a named instance on that same cluster, and then you have it set up in such a way that one instance is running on one node and the other instance is running the other node normally. And then you can have it set up so that it can fail over both instances of one node. And so, that's how it works in my understanding. And that's used to be called active, but that's not really the technical name. It's, 2 nodes with 2 instances.
Let me see if we have any over here in the GroupBy.
Yeah, I mean, I can see the questions, most of them, I think, but
Yeah.
can you see any others?
I don't know. Somebody says Zoom is confused who is Mindy and who is Glenn. It doesn't look confused to me.
Yeah.
I don't know. I don't wait. See, so let me go back into the Q&A. I think I answered that one. You answered that one. So those are done. And then over in the chat, I don't see. Let me back up through them.
Well, I saw one question. Somebody said, "Can I share this presentation with my boss?" Yeah, you
Oh,
can.
yeah.
I've
I said,
updated.
well, I answered that. I said that
Yeah.
the GroupBy is going to have the presentations, I think, in mid-November out on the GroupBy channel and on YouTube.
Yeah, and I'll have the PDF up on my blog. So if you want to get the PDF before that, you should be able to.
Can you post that slide again that has your blog and contact info?
Yeah. So we'll go back to this.
There you go.
So it's just glensqlperformance.com is my blog, but that's the bit.ly link to it also.
And there's one more question. Do you see it? How well does replication and distribution AG work together in the different SQL versions?
Yeah, well, that's a complicated question. Newer versions of SQL Server have a better story there. So I would try to be on at least SQL Server 2016 or newer, but there's some fairly tricky things you got to do if you're using AGs and replication together to make sure it works properly. And I don't really want to get into that right now because I'd have to think about it, but yeah, it can be tricky. And newer versions have a better story is the main answer.
I see Harry has joined us and he has a halo on his head.
Yeah.
I am not a good Zoom user. I couldn't even figure out how to do different backgrounds. This is really my house.
Yeah, same here.
I finally had to call my son in and be like, help me with Zoom.
This is left over from our last user group meeting.
Oh.
Let me turn that off. Let's see.
So you
Well,
ready to build any new PCs, Harry?
I actually been just waiting patiently for the 3090 to come out. You know, just be able to find one to order. But yeah, actually, I was gonna ask you about. I need to find a bigger case because my water cooler doesn't fit in my current case because it's more of a like a, I would say medium size ATX case, but
Okay.
yeah,
Yeah, well, shoot me something offline, what case you
yep,
have, and I can give you some suggestions.
for sure.
Yeah, in case people don't know, I'm kind of a PC hardware nut, so I'm always giving people advice, sometimes unsolicited, about what kind of hardware they might want. So
He's really good at making sure you get in trouble with your wife because you spend too much money in your PC.
yeah, but she wants a new PC herself, last I heard. So
Yeah, that's the problem too.
okay.
So what are you going to be talking about, Harry? What's your
Introduction to getting started with PowerShell for DBA. So
Oh, great.
I'm just gonna walk through, just kind of get people going on PowerShell, and because when I first started, like I have no idea what to do, and the commands are commands. Like there's so many things going on. I'm just so scared of running something that I don't know, and taking down production, for example, by accident, right?
Yeah.
It's just one of those, like, I can imagine a lot of people out there probably having the same issue I was. So, why not just let's do this? Because doing this
Yeah.
session actually makes me learn more about PowerShell than
That's
I've
true.
ever done
Yep.
before. So it's
Well, that's all. When they show you and they go, oh, you can use this and you can hit all the SQL servers in your domain with one command. And I'm like, yeah, I'm not touching that.
yes, that could be scary.
I'm going to make dang sure I understand what's going on before I pull that one out. Because, yeah.
No, for sure.
It's like it's not explaining to somebody how a pressure cooker works, right? Oh yeah, just cook some peas with it. It'll be fine. You're like, really?
Yeah.
I'm scared of that thing.
Yeah, that is.
Yeah, well, I just want to thank everybody who listened to this, and thanks to Mindy for moderating.
Oh, it was simple. You're welcome. My pleasure. One of the easiest